Hey everybody, what's up? Mr. Miller here. It is Friday, November 16th, almost 4 o'clock. And I wanted to make a YouTube video on Cramer's rule, which we looked at today in class. At first, Cramer's rule looks daunting. There's a lot going on. It looks very busy. Most of you probably have not seen Cramer's rule before, so seeing it for the first time, it can sort of grab you by the face and shake you a little bit because it's so new, it's so shiny and new that it rocks your world a little bit. Well, that's good for you. It's good to see new stuff. And as we start going through the remainder of this semester and especially next semester, virtually everything you see is going to be shiny and new. So it's good for you to have that experience now and get used to it because that's going to be happening a lot more and more. Seeing new material, having to learn new stuff. I don't know if you've ever seen the show Seinfeld, but the guy that you're looking at, this guy right here, is Cosmo Cramer. Seinfeld was a big hit show in the 90s when I was a lot younger and I had a lot more hair on my head. If you haven't seen Seinfeld before, I encourage you to YouTube it and watch a couple of episodes. It really was a funny sitcom. And even though it's been years since they've made an episode of Seinfeld, I still enjoy the series. I still like watching the old episodes. All right, let's get right down to business and look at Cramer's rule. So let's say that we want to solve a system of equations in two variables. Whoops. Whoopsie. Okay. ax plus by equals m. cx plus dy equals n. A, C, B, D, M, and N. Those are all going to represent numbers in our system. Right now, this looks really weird because it's nothing but letters. It's alphabet soup. When we start doing a system that has numbers, this will make a lot more sense. Now, Cramer's rule makes use of determinants. And remember that to find the x-coordinate, we take the determinant of x and we divide by the big dog determinant. And our y-coordinate we get by taking the determinant of y and we divide it by the big dog determinant. Now you might be wondering, what is all that stuff? dx, d, what the heck? Those are determinants that we get by using the numbers that are going to be in our system. And when we get to our first example, we'll have numbers to use. But right now, this is just very general. So let's look at what's our big dog determinant. How do we get the big dog determinant? The big dog determinant you get by dropping in your coefficients. Your coefficients on x for the first column, AC, and your second column is going to be your coefficients on y. An important thing to remember is columns go north and south, or up and down, and rows go left to right. Rows, right, both start with R. Right, right. Okay, rows right, columns up and down, right? Rows, right, columns up and down. All right, now to compute a determinant, because this looks really weird. These look like absolute value bars, but they're not. They're not absolute value bars at all. It's just notation for determinants. We go upper left times lower right, A times D. Then we subtract out the upper right times lower left, B times C. In other words, we take cross products and subtract them. Now, our dx we get by utilizing the constants on the right, whatever these might be, m and n, and those go into your matrix first for dx. mn. Here's the weird thing. Because we're looking for the determinant of x, we don't include anything related to x. So A and C, they're out of the picture. We're going to drop in our B and D. And to compute that determinant, you do it the same way you did this one. Upper left times lower right. Upper right times lower left. And then we subtract the two. For the determinant of y, This is where things really get funky. So the m and n that we put in our determinant of x actually gets shifted over to the second column now. Similarly to the determinant of x, where we ignored the things related to x, the a and the c, the coefficients on x, we do the same thing with y. We're looking for y, but we don't care about the coefficients on y for the determinant of y. It's really weird. The first column of your dy is going to be, are going to be the coefficients on your x. And to compute this determinant, it's the same type of deal. We go upper left times lower right, a times n, minus upper right times lower left, mc. Okay, if you need to pause the video, copy this down because I need space and I'm going to have to move to the next slide. In my mind, I already have this material internalized, so I don't need to have it in front of me, but you might, and that's okay. I mean, you're learning it, so that's cool. But I don't have the space to keep what I have here and do our example. Pause the video and then hit play. We'll get started with our first example. All right, so let's apply Cramer's rule. To solve, oh, what looks delicious on this paper? How about this? 3x minus 8y equals positive 9. And we're going to have a negative 5x plus 3y equals 16. All right, so remember that in order to solve using Cramer's rule, we have to make use of our determinants. So determinant, big dog determinant, I should say. Remember, we get that by dropping in the numbers that are touching our letters. 3, negative 5. Negative, the sign is very important. The minus that's on this 8 has to carry. Negative 8 and positive 3. If that sign is left off of that 8, it doesn't matter what you do after that. The whole problem is screwed. Everything you do will be garbage after that. And I'm not criticizing because I make mistakes too, but we want to try to avoid that because the goal is to get the right answer. So to compute this determinant, we're going to go upper left times lower right, 3 times 3, and then we're going to subtract out the upper right times the lower left. So let's see. Oh, well, who cares? So what if it's in blue? It's very pretty. Negative 8 times negative 5. Okay, so if we compute that, we're going to get 9. Let's be very careful with signs. We got a negative and a negative and a negative, all being multiplied together, so that's going to make overall minus. I'm going to ignore this subtraction symbol, which doubled that as a negative, and I'm just going to focus on this part right here. What's negative 8 times negative 5? 40. And 9 minus 40 makes negative 31. Yuck. Okay, don't let the numbers scare you. It's okay if they come out weird because in the end they'll likely come out to work out to something that's prettier to look at. Negative 31 doesn't look so friendly to me right now, but let's see what happens. Let's just keep rolling with this. Now let's find our determinant of x. Determinant of x we get by dropping in our constants that are on the right, 9 and 16. We want x. We want the determinant of x, so we ignore the coefficients on x and drop in the coefficients on y, negative 8 and positive 3. And we compute that determinant the same way we did this one. We're going to go 9 times 3 minus negative 8 times 16. So what is that? 9 times 3 is 27. This is going to end up being plus because we only have 2 negatives to deal with now. Oh my gosh, 8 times 16. I'm trying to do it mentally. What is that, 128? You know what, I better check. It'd be really embarrassing to keep going and then that ends up being wrong. 128. Okay, I was right. Okay, here 155 when we add those two suckers together. Okay, now we need to do our dy, determinant of y. And with the determinant of y, the coefficients go in last. So here for x, they were first. For y, they're last. So maybe a good way to remember that is just like in an ordered pair, x, y, x comes first. Well, here the constants go first. Here's y. In an ordered pair, y is typically the second coordinate. So our constants are going to go last. And now, because we want the determinant of y, we ignore the coefficients on y, and we're going to drop in the coefficients on x in the first column. 3, negative 5. Okay, compute that determinant. 3 times 16 minus 9 times negative 5. Squeezed it in. Never enough board space. Okay, equals 48. What is that going to be? Plus 45? And what is that? 93. Okay, positivo. All right, with me so far? I'm going to just scooch this up. How do I scooch this up? Extend page. Thank you. Okay, so now I'm going to do this in red. To find our x coordinate, we take the determinant of x, divide by the big dog determinant. What was our dx? Well, our dx was 155. 155 divided by the big dog determinant, negative 31. So what does this equal? This equals negative 5. To find our y coordinate, we take the determinant of y, which is 93, and we divide by the big dog determinant, which is negative 31. And this tells us that our y coordinate of our solution is negative 3. So as an ordered pair, the solution is negative 5, negative 3, and we are done. Closing remark. It took about 10 minutes for me to walk through that, but keep in mind I'm doing things step by step, super slow, to help us understand how I'm getting what I'm getting. Once you get this process down, I'm confident you'd be able to whip through this a lot faster, but it's going to take time and practice to internalize it. All right, that's it. I hope you enjoyed the video, and I hope you have a great weekend, and I will see you next week, and we will do more Cramer's rule. Bye-bye.